All right, today we're going to take our discussion further on solving equations. Now, we're really good at solving one variable equations. 2x plus 7 equals 13. One variable, the x. We could easily solve this. Today we're going to talk about solving multivariable problems. X, y, and z. Notice there are 3 variables in this equation with only one equal sign. Now, before we jump into this, let's make sure we understand this. If I have an equation at the top, there's an equal sign, so it's not an expression, it's an equation, and it's only one variable. X, x on this side. Over here we got an x and an x. No other variables. Thus, because the other things are values, we can solve this equation. We can find the value for which it's true. Yeah, it's our old procedure. Combine like terms on each side, which you notice I've marked. 4x and negative 2x become 2x. 12, negative 3, and positive 4 become plus 13. On the other side, 6x plus 5x is 11x. And the other two values, negative 3, negative 2, become negative 5. Combine like terms each side. Step 2, right? Get the variables on one side that you want to solve for. We want to solve for x. So I move 2x to the right side by subtracting 2x on both sides. And then I have 9x minus 5 equals 13. Move the constant, or get the variable by itself is a better way to say it. I want 9x by itself, so everything with 9x has got to go away. So I send negative 5 to the other side by adding 5 to both sides. Because these are like terms, I can add them. 13 plus 5 is 18. Divide both sides. Now I look and I say I have 9x equals 18. How do I get rid of multiply by 9? I divide by 9, both sides, every term, there's only 2. And I get x is equal to 2, or x is equal to 2. It doesn't change for this. On the right side, we have a two-step equation. Subtract 7, or the left side, I'm sorry, the left. And I get 2x equals 6, 2 terms. So I divide, or I have the variable I want to solve for by itself, and I get rid of the coefficient, and I have x equals 3. Now, on the other side, I replace 7 and 13 with y and z. Now it's a multivariable equation. I'm going to still solve for x. I look at this, there's nothing to combine on both sides. I have to get the x term by itself. There's only one x, so I don't have to worry about moving x's side to side yet. So I send y to the other side, minus y on both sides. Y minus y is 0. That leaves 2x on the left. On the right, z and y are not like terms. Cats and dogs. Z minus y cannot be combined. It has to be left as one thing. So I have 2x equals, and I can put z minus y in parentheses to treat it like one thing. Well, again, I want to get x by itself. I have to get rid of the coefficient. To do that, I must divide. So I divide by 2 on both sides. And that gives me x equals z minus y over 2. Or I can divide both terms. X equals z over 2 minus y over 2. Alright, so I'm going to do a couple of these. And I'm going to go as fast as I can while trying to talk through it. You can try to solve these. I'm going to solve for y on both of these. On the first one on the left, I see 6y minus x plus z equals 4. Now, I have to get 6y by itself, so I have to get rid of minus x by adding x. And at the same time, I'm going to get rid of plus z. I'm going to subtract z. And what I get on the left side is 6y. The x's cancel, z cancel. On the right side, I have 4 plus x minus z. None of those are like terms. Dog, cat, goldfish. All different. Alright, so I write it out. 4 plus x minus z. There's nothing I can do. Now I have 6 times y. Well, if I want to get rid of the coefficient, I have to divide. But if I divide, I must divide every single term. Now I could make this one thing, but I prefer we get used to this type of thought. So I divide every coefficient by 6. And I get y equals, 4 divided by 6 is 2/3, plus, we know there's a 1 here, so I'm going to write this as 1/6 x. And again, I'm going to write this as minus 1/6 z. Takes practice. On the other side, I have to do some work here. You have to catch there's a y on both sides. Before we do anything else, we have to get the y's together. So I either have to move the y on the right side to the left, or the negative 2y on the left to the right. I always personally move the negative value. If I do that, I'm going to get 4x plus 2, not like terms. Y plus 2y is 3y. Now I have to get the 3y by itself. So I'm going to add 4 to get rid of the negative 4. Now where should I put the plus 4? Well, I should put it under the like term. I can't add 4 to 4x, but can I add 4 to 2? Sure. 4x plus 6 is equal to 3y. How do I get rid of the 3? It's 3 times y. I have to divide all terms. I get 4 over 3x. 6 divided by 3, do we all agree that's 2? And that equals y. And I have solved for y on both those equations. Again, we keep on rolling. It doesn't have to be y or x. Here, the equation is solve for the letter p. And the first thing I do is I say, is there any like terms? P, a, and negative 5 are not like terms. On the other side, 6a plus 3p minus 2p. Ah, hang on. That can be written as 3 minus 2 is 1p, which I'll just write as p. Now, the next step is get all the variables on one side. I have 4p and p. I'm going to have to move a p. And if I do this, I get, and again, you notice I line up everything to the like terms. Alright, now I have 3p. I have 1p in the equation. I have to get this term, the 3p term, by itself. So 2a and negative 5 gotta go bye-bye. So I'll subtract 2a, and since negative 2a is the same as 6a, I'll put it underneath. I'm going to have to add 5. Nothing the same over there. These cancel, and I have 3p equals 6a minus 2a. 6 minus 2, 4. So how about 4a plus 5? And I'll divide both sides by coefficient, which is 3. And I will get that p is equivalent to 4/3 of a plus 5/3. I can solve for any variable I want. I just have to select. Got one more board here, I guess. And again, a lot of times we solve for y. It's going to lead to helping us with lines. So here it is. Solve for y. Now this one's a little simpler. Y is all by itself. There are no like terms on both sides, so I just have to get 8y by itself. So I'm going to send negative 13x and negative 8 to the other side. And again, 13x is not a like term, so I'll write it kind of to the right. Negative 8, if I add 8, 8 and 4 are like terms. These cancel and these cancel. I'm left with 8y. 4 plus 8 is 12 plus 13x. And again, I can get rid of the coefficient because this is 8 times y. The opposite operation of division or multiplication is division. So I do the inverse operation, and I'll do it to all terms. And I get y equals 12/8. Does everybody agree? That's how about 3/2? And 13/8 does not simplify. Now, one small detail. This is correct. I will mark this right. But as we move forward, we always want the variable term first. So I have this term plus this term. 3 plus 4 is 7. Well, 4 plus 3 is still 7. And we'd like to put the variable term first. Solving multiply variable equations, same thing. It's all about equivalency and doing what we need to.